Hello and welcome everybody to this FEDERATE webinar. This webinar today is about FEDERATE's GitHub building block repository. The topics in today's webinar are what is the FEDERATE GitHub building block repository about? Then we will see a short introduction into the wiki and who are the target groups of the repository. Then we will get something about the task of the project and the repository. Then we will see why it's worthwhile and useful to work with this repository. Then we will go through the structure of collaboration, which we have seen in the last webinar. And we will talk a bit about the structure, the architecture, building block types and areas. We will see how we can map this structure of collaboration to the GitHub tree structure. Then we will see something about the building block tagging system and something about the building block template. And last but not least, we will show you how to contribute to this GitHub repo. What is FEDERATE's GitHub building block repository about? So if you click on the link, you will get some information there, what the building block repository is about. I will show you that on this screen. So here you see, welcome, the FEDERATE building block repository. This repository contains a structured description of building blocks. It's essential for developing, operating, and evolving the software-defined vehicle with definitions, templates, and conventions to share your SDV-relevant ideas, technical components. And there is no code here. So with this information, we see, okay, this repository contains no code. So FEDERATE does not develop code for building blocks. So it provides a structured description of building blocks. And this description of building blocks you see here in this tree. We will see later on what these provisions mean. But what we're talking here is about different eras around the software-defined vehicle. So we're talking about developing as building blocks, operating, evolving, and so on. Then a short intro. If you want to start with this repository, so the best way is to go to the wiki. So if you go to the wiki, then you will see again a welcome slide. And here is some introduction about the FEDERATE building block repository in general. And this says this wiki will walk you through the process of contributing in new building blocks to support the open software-defined vehicle ecosystem. Wherever you are, a developer, an architect, a researcher, system integrator, or if you are working everywhere around the SDV, you're on the right place here. So you have a component, an idea, or a gap to share. You can contribute it to this repository. So in this repository, we collect everything which is related to the SDV. And at the end, what you get here is a single point of information where you can start, where you can see what is out there, what building blocks exist. So where are gaps which needs an implementation, where are descriptions of building blocks which needs partners to implement, and so on. What is the task about this project? So again, we jump to the wiki page and there is some information about it. So if we are here, we say, okay, one of the goals of this FEDERATE project is to provide a shared structured understanding of what is needed to build an open and collaborative SDV ecosystem. This involves three core tasks. So the first one is defining a common language and a curated glossary for building blocks and SDV-related terms, ensuring clarity and alignment across contributors, domains, and areas. So that means you see here on the right hand side a glossary, and there are some definitions. So to get a common understanding about building blocks, about building block tags, areas, and examples. We'll see that later on. Another thing is we collect and map building block descriptions within a predefined architectural landscape, making it easier to identify, compare, and connect solutions across the ecosystem. So if you look at this picture at the bottom, you see on the left-hand side, there is a screenshot of the folder structure of this GitHub repository where building blocks or building block descriptions are collected. So with these building blocks, we can map them to some kind of architecture. So on this left architecture picture. So it's a layered architecture. It should represent the in-vehicle stack. And you see, if you take building blocks, you can localize them there. In the middle, there is a layered architecture about tools. So there are also building blocks. And on the right hand of this architecture picture, there is the cloud. There are no building blocks in this description. And at the bottom, there are some support building blocks like patterns, APIs, and other descriptions. So that's all descriptions of building blocks. And at the end, you should be able to take some of these building blocks, bring them together, compile them, build them together, and execute one instance of a reference core stack, let's say, with a tool chain and with some processes and APIs, whatever is aligned. So in general, this federate should act as a neutral integration layer, bringing together fragmented efforts and enabling alignment around interfaces, design patterns, and best practices. So it should help individuals, projects, and organizations find the common ground and build towards a compatible, sustainable solution for mobility software of the future. So that's, let's say, the main task of the FEDERATE project. Why it makes sense to join this project, to contribute to this project, or to at least have a look at it if you use this project. So you got some kind, or what we offer here is a unique and practical advantage for everyone who is navigating to this complex landscape of these building blocks. So there are several building blocks out there which can be used. So for one and the same, let's say, technical solution, there are several implementations out there. And in this repository, we collect all of them. So it's not our goal to say we have found every building block or every building block is there. But this visibility enables stakeholders, for example, to quickly identify overlaps and collaboration potential between existing efforts, reduce duplications of effort by seeing what is already available, or you can bundle your resources by coordinating efforts across initiatives. So it should be some kind of single point of information where different partners, different organizations, projects offer their services they implement with a building block description, or other projects who have or searching for partners can see what's going on there. Or if you have a gap detected, so you can write a building block description where you say that's a service or a building block which is needed but does not exist, and you also put it there, and you're searching for partners or a project who wants to implement this building block. As you can remember, in the second webinar, you've seen the structure of collaboration. So that means we have here a layered architecture or structure on different layers, well known. There is at the bottom the hardware platform, then there is the software, then we have applications, and then we have some kind of tools. In the middle here, you see, okay, there is some software running in the in-vehicle stack. There is some software running in the cloud. At the top, we have some tools to develop these building blocks. And there's also was the explanation that this SDV of the Future Initiative works on this top and on this middle layer. So where this RISC-V or RISC-V initiative works on the bottom of the hardware platform. So for us, how to map that to our architecture, let's say, we have defined so-called building block areas for that. So that, for example, here you have this area SDV in vehicle. So it means if a building block is in this area, then it's running in the vehicle stack. Or if it's in this area SDV cloud, then it runs in some of these clouds we have defined. So there are several clouds. There is an on-premise cloud, for example, a service provider cloud, and others. So, and at the top, we have this R&D cloud where we have our research and development tools. So to go to this page again, so you see there are some definitions of areas, and in all these areas, you will find building blocks. So there are SDKs and development tools in the R&D area, on the on-premise cloud. So you have maybe some simulations models running, or some tests or build tool chains. You have this in-vehicle area where all these in-vehicle stack components are running. You have service providers, for example, network provider, telecommunication provider. Then there is this enterprise and resource planning where you manage all resources or the vehicle fleet. And there is the customer area where maybe the smartphone of your customer is connected and so on. The question is now how to map this finally to this GitHub tree structure. And for that, we have defined some tagging system, and that was implemented here. As you've seen in the beginning, there are these root folders with these abbreviations where PP stands always for building block, and then we have some other abbreviations at the end. And that is some tagging system to make it easier to localize and find out where building blocks are. Let's start with some generic descriptions. So the first thing what we have done is we have to define what building blocks are. And for that, you can go to the wiki and do these building blocks and then to the building block tags. I will do that right now. So if you go to these building blocks, you will see there are some definitions what we in FEDERATE has defined as a building block. And there is a generic definition which says a building block is an executable code or a usable library within the car, within the cloud, within the development environment. So this could be a proprietary implementation as well as an open source or an interface implementation. There could be an API or whatever is needed. So it means a building block could be everything in this case. And there are also building blocks defined that we need to develop, to verify, to validate, to operate, to support and to maintain software components. So that means a building block could also be a tool, a process, whatever. So there are a lot of definitions there what the building block could be. And to bring that to let's say, a concept so that we can use that architecture picture or map that in our structure, in our, let's say, tree structure, we have done implemented a tagging system, let's say. And this tagging system describes then at least the building blocks we are talking here in this SDV areas. So if there is a tag called BPSC, that means that's a building block stack component. So and this stack component is always an executable or a library which is running within the car. If there is an C before this SC, for example, that means cloud, then it's cloud stack building block. So that's always an executable, a library, whatever, which is running in the cloud. Then we have defined building blocks, which are mockups. So that means if you have a proprietary implementation where you only want to offer an API or an interface to it, then you can tag it with this building block mockup unit tag. The same for the cloud. If there's something which is running in the cloud, tag it with this PP. CMU. Another building block tag category is this BPEST, which stands for Building Block Engineering and Support Tools. So that means this tag says there are tools which are used to develop BP stack components. We have the same for CSD. That means that are tools which are used in the cloud or to develop cloud stack components. You can group this ESD building block descriptions or building blocks and the CASD building blocks to tool chains so that you can use them together. And at the end, we have this SBB. That means we have some kind of support building block. So that is everything which has no implementation, which is some kind of rule, some regulation, standard, best practice, some description you need or develop against. Have a look at this picture again and try to map this. Then we say, okay, we have seen this in-vehicle area, and here we have this BPSC building blocks. So that means everything here is running in the vehicle. If it has this tag, then it's a cloud building block. If it's an BPESD, CSD, ESD toolchain, then it's some kind of tool which is used to develop. And at the right-hand side, for sure, we have the support building blocks where we find best practices, patterns, API, processes, standards, regulations, whatever is out there, which has no implementation, but is needed to implement. So if you have these areas, and we have seen this on this root file system at the beginning, so there are these tags, but there are a lot of stack components which are running in the vehicle, and for that only this folder is not enough. And for that, we have defined some additional, let's say, layers, classes, subclasses, and functional clusters. On the first thing, the layers, you see if we are talking about the stack components, which is an in-vehicle software. Then there are 4 layers. There's the hardware layer, so that's this RISC-V or RISC-V initiative is working on that, but we use some interfaces from them. Then we have the OS layer, where we provide building blocks for which describes OS components, then something for middleware, and the application layer. So in that, we have defined, for example, here for this cloud engineering support tools, some classes and subclasses. So there may be tools for artificial intelligence and machine learning. And in this class, we have subclasses. So there are tools for data-centric AI development, data-centric validation and test, and so on and so on. And last but not least, there are also the functional clusters, well known in the automotive industry, let's say, as they also defined in AUTOSAR. If you go to this middleware layer, for example, here you have a functional cluster for communication, for configuration, for diagnostics, and so on. So that's an additional structure and make it easier to navigate in this GitHub repo. So at the end of this tree or path, let's say, there is always a building block description file then, which describes the final building block, which we're talking about here. And for that, we have implemented a template so that you have some guideline how to describe your building block. To do that, so you can use the building block template, open it, and describe your building block in a simple way. So it's always the same. We start with the name of the building block. So if it's an implementation for, or it's a library, then add a library for whatever. Then you add your tag. So that means if it's a tool, then it's BPEST. If it's a stack component running in the vehicle, then it's BPSC. You can also add several tags here if it's fits to several tags. Then you add the functional cluster. So if it's an BPSC and it's running on the communication side, then add here communication. Then the layer, you see here app layer, middleware, OS layer, if you've seen it before. Then you can add some usage here. And then an important link, that's the known implementation. So that's what we've mentioned at the beginning. FEDERATE does not implement code. We only provide building block descriptions so that we say there is a solution for something or there's a solution needed. And here is a reference to the implementation if there is one. So then we have a description about the building block. That's some general description, what it does, so rationale, what problem you want to solve with it. Then there is the governance applicable SPPs. So if you have to fulfill some regulations or have to develop against some standards, then edit here, the standards is known. Then compose, if it exists of several building blocks, is a huge building block. Then what is needed to design and implement? Is there some special hardware needed or whatever? What is needed to build and run? So are there special tools needed, special compilers and so on? Did your building block have description have some non-functional requirements? Let's say it's safety or security related, or it needs a real-time runtime environment. Are there dependencies to other clusters, let's say? So if you have a building block which needed some building blocks from the security, or you want to, building block wants to store, make data persistence, then it has dependencies to the storage cluster. Is this relevant to the vehicle API? So let's say if there is something like the Covesa VSS, for example, where you have this vehicle signal specification and your building blocks adds additional, let's say, signals which are not in this VSS, for example, you can say here yes, and then we try to get in contact with Covesa or organize a contact so that we can discuss if it makes sense to push this also to this, let's say, group. Then there is the author and the company who wants to work on this building block or who offers the building block if an implementation is there. Then there is a field for priority. You can say, okay, it's high priority, so I need some partners to implement or work on that. Then related projects. So if there are other projects using this building block, for example, you say here, for example, Eclipse blueprints or wherever it's used, where I can say a short demo or use case with the building block. Then something about the availability of source code. So if it's an open source implementation, then say yes and add a license here. If no, then it's a commercial license and maybe the API is available as open source building block. Then you say here yes and which license it is. So then we have the type of the API which we offer here, or the building block offers. Is it a web API, a library, open system API, database API? Then there is a field for potential obstacles. So that means, are there some hindrances to implement that, or what we have to think about, or something needs to be discussed? Then there is a field about this maturity batches that's coming from the Eclipse SDV process working group. So they have for their, let's say, tools or building blocks or implementations are worked out some kind of maturity batches where you can say you have a documentation and some kind of level of the documentation. Same for the requirements, coding guidelines and tests, or for the release process. And here's an example. So if you say I have a building block and the documentation is level gold, so that means everything is documented, but there are no requirements wherever, but there are no ones available. There are coding guidelines not defined, so nobody knows. We have to clarify that. For testing, there are some test cases available, but not all its components are tested. And there is a release process. Yeah, we work it, but yeah, it's not fully implemented. Then it's silver or something else. So then there is a field needed skills and training. So that's important for open source projects where you say, okay, if you want to work with that building block, then you need that, this and that skills. And here we offer trainings or getting starting guidelines. Then you're at the link here for that. So, and at the end of this, there is a field for the state. So that was some request for the OEMs, let's say. They want to know if this building block is used in production, maybe by one OEM or another company. It doesn't mean automotive, be everywhere, or it's still incubating, so there's no code yet, or the first public release is available, so it has some state with a date when we have checked that. Then there is a field for the system context, so that means what runtime environment is needed or where to execute this. And the end, there is some Basel compliance status field, so that was a requirement from the SCORE group, because they also aligned and synchronized with that, so that they want to know if this building block can be built with Basel or there are some Basel build scripts available. So, okay, how this looks like in a real world building block, let's say, to see how this could look like. So, for example, if we go in there in this stack component, then we say, okay, there's, for example, middleware layer, then we have this functional cluster communication. So there are different building block descriptions here, and one is RTBS types. We see here we have different implementations of one and the same standard or specification, the DDS. There is fast DDS, open DDS, cyclone DDS, embedded RTBS. There's also a building block about vSUMAB. And here for OpenDDS, for example, there is this building block template. It's a field template. So we have seen, we have here the name of the building block. It's OpenDDS. There is a tag, so it's a stack component, but it could also be executed in the cloud. There are mockups available which only offer DDS communication, but the algorithm inside or whatever is closed. Same for the cloud. So it's from the functional cluster communication. It's running in the middleware layer. The usage is not documented. So the known implementation, there is here the reference. So we can open that. So there is the field for known implementations. And if you click there, we go to this OpenDDS page, and that's where the real implementation exists. So you see here, there is the code of the implementation. There are a lot of contributors working on this, and there is also documentation and what they really did. Back to that building block template. So then there is a description about the building block. So what it is an open source implementation from the object management group specification, data distribution service for real-time systems. So then nothing about the rationale, what is used. So governance and application. Applicable SPBs, so they have TCP support, IP support, UDP, IP support, IP multicast is implemented, shared memory is implemented. There are different specifications here which are implemented. So to compose the building block, they need only a runtime environment, what is needed to design and implement. So there's another link where you have some dependencies which you need to run it. So what is needed to build and run. So here's a list of, let's say, runtime environments and tools which are needed. Non-functional requirements. So we have real-time and quality of services which are supported. Dependencies to other clusters, not yet. Vehicle API relevant? No, but you can implement maybe something which is relevant. So authors, it's provided by anonymous, so author do not want to know who was that. Then we have related projects. So there is this Open DDS org initiative. They are working on that, so we have seen that. Availability of source code, yes, it's open source, and they have their own license for that. Availability of API, there's no description there. Then there is something about these maturity badges, so documentation to say everything is documented, coding guidelines are there, resources are there. So let's click on it, then hopefully the documentation is open, so yes. Then you see here there is a lot of documentation available. So back to the button. Then the state, so checked on January 25, and that's continuously updated the project. So this is a living project with a lot of contributors. Then system context, so whatever you want. So it's running on several operating systems, also in virtualized one, real-time operating system. And Basel compliance status, there is no information about that available. So that's how the building block template used if it's filled. There's one more thing which needs to be mentioned. So that is, if you look at this root folder structure here, where we have all these building blocks, then you will see a folder work in progress. And this folder work in progress means there is the entire root tree mirrored in this. So you have again BPCSD, BPCMU, and that is why, because in the root structure, we have only building block descriptions with a known implementation. So that means if a building block is in the root structure, then there is an implementation still out there. If the building block description is in this work in progress folder, then there is a need for this building block, but there is no implementation or known implementation available right now. So that means if you find a building block in here, you can take it and start working on it, start to implement it. So it's for projects, research projects, and other initiatives. If they say, oh, that's something we are working on, or we have started working last year, then you can also take it and add a reference, and we move it here to this other, or to the root structure, let's say. Okay. So at the end, I will show you how to contribute. So in general, it's like the standard GitHub workflow. The first thing is, if you are not in a maintainer role, so then the only chance you have is to fork the repository. So then you can, if you have the fork in your private, let's say, GitHub environment, then you can clone it to your development machine, configure the sync with the upstream. So there are some links to how to do that. Then identify the right location for the building block you want to contribute. So that means figure out, is it a stack component which is running in the middleware layer in the configuration functional cluster, then add the building block description there. Then copy the building block template to this right location. So here is a reference where to find the template. Then describe the building block. So that means fill the building block with information. Then add and commit it, push it to the forked repo. And then at the end, create a pull request to the origin repo here. So how this looks like, go here to fork. So there is my private account, so I'm logged in with that. So I say, okay, I want to fork it. Then you see now it's on my repo. So I will clone that building block. So copy that here. So, okay, there is a folder webinar. You can say git clone this building block. Do it like that. So then you get a local copy of it. Some proposed building blocks. So if we look in here, we see all this stuff which is cloned. So you see there are a lot of descriptions in there, a lot of folders in this repo. So the important thing is now to find the right place for your building blocks. So if you look at the structure again, you say, okay, there is a building block where I have only an idea or I need this building block, but I have searching for partners. Then I go in this work in progress, for example. Then again, there is this same structure as at the root. If it's something like a stack component, then I go to the stack component folder. Then I say, okay, it's something like middleware where I'm working on or want to work on, and then I have the functional clusters, and they say it's something for runtime, whatever. So then I go in here, there I see there are 2 building block descriptions, and now I copy this template, the building block template, and this building block template, it's in the root directory. I will show it online. So the building block template itself, it's here in the others, then utils, and here you see the template. So that's the template we use to describe our building blocks. So there's all this additional stuff I've shown before in there. You can take that, copy it to the right location, other, utils, pp template, and you will copy it here and give it the right name. So it's pp, it's my runtime component, whatever, .md. Now we have our building block here, then describe your building block. So add your descriptions in here. So let's say this is my building block, and enter all the descriptions you want to have in here or you want to share. pp, my pp, whatever. So I will not fill the whole stuff, so it's here. So it's a good idea to always sync with the, let's say, origin repo. So that's my code, so I haven't done that. If we look at the git remote, you see only our stuff here, but we can say git add remote, remote add the upstream repo, and that's the original one. So you can copy the link, copy that, so enter that here. Now if we check, then we have 2 of them. So the upstream is also there. It's always a good idea before you do that to fetch and check if there are some differences. So get fetch the upstream. We'll say, okay, there are additional branches. You can merge that. So check out your main branch, merge it. There's nothing there. Then you go to add your changes. In that case, to commit your changes. Add your commit message. So then you can push to your online repo, let's say. You can enter your username and your password. And if it's pushed to your local repo, then you can generate a pull request. So that means go to the original repo, enter a pull request, say you want to generate a new pull request, and then go compare across forks, and then you open that, and then you scroll down, you will see your repo where you have a copy of this repo, add this one, and then say we want to generate a pull request. So it's nothing here because I haven't pushed that. And then the maintainers of this repository see the pull request here. They will check it, add comments here, whatever, or they will merge it into the main branch. And then your building block is here and could be seen by others, shared with others, and yeah, others can start collaboration with it. So that's all, let's say, about this FEDERATE GitHub repository. And yeah, with that, I'm at the end of this webinar. And if questions, you can send me an email or add some comments. Thank you very much.